Hi guys, welcome to our video on writing chemical equations. This is part of Unit 4, and to start out Section 1. You'll need your notes, which is your pen and paper, and knowledge of naming different compounds. So let's take a look at chemical equations. They show us pretty much what we start with and what we end with. So if we look at a chemical equation, it's the formulas with arrows and plus signs and big numbers in the front, and they tell us what happens in the reaction. So for example here, we start out with CH4, it's methane, and we can see from the diagram that we have one methane molecule. We also have two oxygens, and remember oxygen is a diatomic molecule, so they come in together, so we have two oxygens. And then after the arrow, we have CO2, carbon dioxide. We have one of those, and then we end up having two hydrogens two waters at the end. We know that this is a chemical change because we actually start out with different reactants and end with different products. Here also represents a chemical equation, but this actually represents one of a physical change. So we have H2OS, that S represents the solid, so here we have ice, and that can produce H2O liquid in the end. Again, we know that this is a physical change because nothing has happened to change the arrangement of the different elements. There's still going to be H2 on the left and H2 on the right. They're just in different states of matter. So chemical equations use chemical symbols. They show what the reactants and products are, and we balance them. So we'll get into balancing them, and you'll be great at that. They also look at the states of matter and identify different changes in the reaction. So again, a physical change versus a chemical change. And to remind you, a physical change is a change of state of matter, or dissolving, and a chemical change can be a variety of things, such as burning or decomposition, anything like that. So we're going to look at different symbols in the chemical equation. Sorry that a few of them have popped up already. That little plus sign represents and, or combines with. The arrow represents yields, produces, or to form. Sometimes we have arrows with different things. So for example, we have arrow with the word yeast on top. That represents a catalyst, whereas an arrow with a triangle represents heat. We can also have arrows with light on top or other different types of catalysts. And we have something here with equilibrium. So we have a double-sided arrow. We can also represent this as this. So we have two arrows with only part of the head showing, and they're each going in different directions. So that represents equilibrium. So another different symbols are the states of matter. So we can have an AQ, and notice that these are smaller. They're subscript behind the chemical formula. So AQ represents aqueous, L represents liquid, S is a solid, and G is a gas. Let's also remind ourselves that, aqueous is something mixed in with water. It is not the same as liquid. A liquid is when we go from a solid from a solid to a liquid, or then from a gas. So here, from a solid to a liquid, we're melting. Liquid to a gas, we're evaporating. These can also be double-sided arrows to represent the opposite. So, going from a gas to a liquid represents condensation, and a liquid to a solid represents freezing. So again, liquid is not the same as aqueous. Here's a chemical equation. We have 2HCl, AQ, plus CRS produces, that arrow represents produces or yields, CrCl2, AQ, and H2G. So the substances on the left-hand side of the arrow are called the reactants, and the substances on the right-hand side are called the products. We need to make sure we know how to name these as well. So HCl, we know is hydrochloric acid, and it's aqueous. So we say aqueous hydrochloric acid. There is added to, so aqueous hydrochloric acid is added to solid chromium to produce or yield aqueous chromium 2 chloride and hydrogen gas. So those numbers in the front of the chemical equation in the front of the chemical formula will represent the fact that we need twice as many HCl molecules as we do Cr molecules in order to produce those products. So let's do a little bit of practice. And I have a flowchart here if you don't remember this from class or may not have used this in class, but this kind of actually helps you identify how to name different things. So we have zinc. It's one element and a metal, so it's just going to represent it as Zn. We're assuming at STP, or standard temperature and pressure, so zinc is a solid at standard temperature and pressure. The and will be our plus sign. And then aqueous lead 2 nitrate. So we have lead 2, which is Pb. Nitrate is NO3 from table E. And we know that Pb is a plus 2, nitrate's minus 1, so when we crisscross, we have Pb NO3 2. And it said here that it was an aqueous, so I'm going to write the aqueous. Then, so we've taken care of this, and then this part. We have yields, so I'm going to draw my arrow. Aqueous zinc nitrate, so I have Zn. Zn is a plus 2 charge. I know that by looking at my periodic table. NO3 is nitrate, and again, nitrate is only a minus 1, so there should be twice as many nitrates. And then we have and, which is my plus sign, lead, which is Pb, and that's solid at STP. I also forgot to put in, excuse me, the state of matter for the zinc nitrate, so that's AQ. Going on to the next one, aqueous aluminum bromide and chlorine yields aqueous aluminum chloride and bromine. So aluminum bromide, we know by naming is AlBr3. We have a plus sign here. Oh, excuse me, that's supposed to be aqueous. The plus sign. Chlorine. So chlorine is one element, it's a nonmetal, and actually falls into the Hunkelbriefs, so we have to make sure that it's Cl2. We know Cl2 is going to be a gas at standard temperature and pressure because we follow the rule of 17 for the nonmetals. We know it yields aqueous aluminum chloride, AlCl3, and that was aqueous, and, which is that plus sign, bromine. So again, going down through, bromine is one element, it's a nonmetal, and also happens to be one of the diatomic molecules, so it's Br2. And I know my states of matter, at STP, bromine is going to be a liquid. Number 3, aqueous sodium phosphate and aqueous calcium chloride yield solid calcium phosphate and aqueous sodium chloride. So I have sodium phosphate, that's NaPO4. That phosphate is a minus 3 charge. Sodium is only plus 1, so it's 3 next to that sodium. The equation, the written form says aqueous, so I'm going to write an AQ. I'm writing a plus sign for the and. And we have aqueous calcium chloride, so I have Ca, Cl2, AQ. It yields or produces, so I show the arrow, solid calcium phosphate. So I have Ca, PO4, calcium is a plus 2, so there's 2 phosphates. PO4 is a minus 3, so there's 3 calciums. And that was solid. And I'm running out of room, otherwise I would continue on the right, but aqueous sodium chloride. So I know sodium is Na, chlorine is Cl, and that should be aqueous, AQ. And the fourth one, solid potassium chlorate, when heated yields solid potassium chloride and oxygen gas. So solid potassium chlorate, I have K for potassium. Chlorate is ClO3, that's a solid. And it says when heated, so I know I've added heat to here. I can go ahead and use that arrow with the triangle on top to represent that heat. Solid potassium chloride, so KCl, solid, and oxygen gas. Remember, oxygen is one of the diatomic molecules, so it should have a 2 right next to it. And number 5, aluminum and hydrochloric acid yields solid aluminum chloride and hydrogen gas. So aluminum is just one metal by itself, and since it's not mercury, it's going to be a solid. We have and hydrochloric acid, so I'm going to use my reference table. If it says acid, I know that I can use table K, to figure out that it's hydrochloric acid, all of which are aqueous, and then solid aluminum chloride, so AlCl3, solid, and then hydrogen gas. Hydrogen is H2, and a gas. So for number 6, solid calcium hydroxide and phosphoric acid yield aqueous calcium phosphate and water. So calcium hydroxide is CaOH2, and that said it was a solid. Phosphoric acid, I can use table K, H3PO4, and they're going to be aqueous. Yields, which is that arrow, calcium phosphate, so calcium is a +2, phosphate's a -3, so it should be 3 calciums for every 2 phosphates. And they said it was an aqueous, and water. And at standard temperature pressure, we can assume that that water is going to be a liquid. Alright, so number 7. Copper and sulfuric acid yields aqueous copper 2 sulfate, water, and gaseous sulfur dioxide. So we have copper, Cu, it's solid at standard temperature and pressure. Sulfuric acid, H2SO4, which is aqueous. Yields, which is that arrow, copper 2 sulfate. So we know that the copper is a +2, sulfate is a -2, so they both cancel. So it's CuSO4, and it said it was aqueous. Water, which is liquid, and gaseous sulfur dioxide. So it's SO2 gas. So to summarize, we can represent chemical equations, and we can determine from them that they are going to be physical or chemical changes. We use different symbols such as a plus sign and the arrow, double-sided arrow, an arrow with a triangle on top, an arrow with a name on top, just to represent different things. And we can also use the states of matter to help us figure out what happens in our chemical equations. Have a good day, guys. Take care.